Okay, now let's start with exercise 5. These are actually simpler exercises. Let's take a look what it asks. So take an integer n as an input and return a matrix of size n by n. Okay, where all the elements are 0. So the first I have asked to create a matrix like this. This is 0, 0, 0, 3 rows and 3 columns. Now, so you can do this using for loop, but that is obviously we are not going to do using MATLAB. So let's do something. Okay, let's try something. Exercise 5. The previous one was supposed to be exercise 4. Okay, let's see. So first of all, the one is I have to create a matrix of size n, right? So n equals to 3. Let's keep it now. So there is something, a built-in function that is called zeros. Okay, if I write something like zeros of n, okay, and let's run it. Let's see what actually happens. So this zeros function automatically creates this 3 by 3 matrix. Okay, zeros is a built-in function that automatically creates this 0, 0, 0 by 0 matrix. If I write something like t11 is equals to ones of n, okay, it will create a matrix of everything with 1. Okay, these are two special cases. There is no 2s or 3s, like not like that, only zeros and ones. Okay, so we have learned two new functions. Okay, let's add it here. That is zeros so two new functions we have learned, zeros and ones. And let's go back. Let's take a look at our question. So the first question is done. The second question is asked that n plus 1, n plus 1. I have to create a matrix of n plus 1. If n is equals to 3, that means I have to create a matrix of 4 by 4, where all the elements are 5. Okay, so we can do that. Okay, we can do that by this is our task 2. Task 2 is equals to, we can write ones of n plus 1. And see one thing, we are actually, this is actually creating a square matrix. If you remember a square matrix, the number of rows and number of columns are same. Okay, so by using writing t2, I'm actually creating a square matrix of size n plus 1. Let's do this first. Okay, so I have this 4 by 4 matrix, but I want here, I want every element to be 5. So we can just simply multiply this with 5 and it will automatically work. So let's just multiply it with 5. Let's see how it actually happens. So simply, so I am not multiplying with an complete matrix. I am just multiplying with an element, and it is performing this element-wise multiplication. Okay, so this will actually become much more clear when you actually practice a lot. And let's take a look at the third question. So I have to create a matrix of 1 comma n, 1 by n, where all the elements are -8. Okay, now previously, so far we have actually created an square matrix, but we can also create something that is called not square. Okay, so let's say t3 is equals to ones of, I'm asked to create a matrix of size 1 comma 3. So we can actually define this size this way. If I use only one, okay, 1 comma n, actually, because we are using n by default. Okay, 1 comma n. Okay, so it will actually create a matrix. We run it. So it will actually create a matrix 1 by 3, and we are asked to make that so that all the elements are -8. We can just multiply it with -8. Okay, and let's see our output. So everything is -8. Okay, these are a pretty simple exercise. Okay, let's take a look at it again. So I have asked to create a n comma 1 where all the elements are 25. Okay, I believe you can do it by yourself. And n comma n plus 4, I believe you can also do it by yourself. So this try these things by yourself. I think there will be no problem. Okay, also try for another value n equals to 8. Now one of the other thing that I want to show you is something like this. This is called input, and I am providing a prompt that is enter the value of n. So what it does is when you run it, it will ask for a value. I have to enter a value here. Let's say enter 8. Then so all the things that is here are actually calculating for this value we actually entered. So this way we can actually interact with the user. I can try out different values. So for example, if I run with values of 2, it will actually give me, it will perform all the functions, all the codes that we have written here for that value of n. So this is the input prompt. Okay, so it is also something that you want to enter here. Okay, so this is our input. Okay, we have to put some prompt here. Okay, so I believe that's okay. All right, now let's start with exercise 7. Okay, so in this exercise, a matrix is given. This is the matrix that has been given, and I am asked to perform this following operations. So let's first copy this matrix. Okay. Copy this matrix, and this is our original matrix. Okay, now let's see what you are asked to do. We are asked to create a random matrix of size 4,2, then multiply it with A. So we have to create a random matrix. Okay, so how do you create a random matrix? There is a built-in function for that. This is the random matrix of size 4,2. Okay, so that is, let's name it as M1. So rand is the built-in function, and this is the size 4,2. So this is the matrix that has been created, and we are asked to multiply it with A. So let's multiply A by M1. I'm using this multiplication side. Okay, so if you remember from your intermediate, okay, if I do some matrix manipulation, like if the size of the matrix is A comma B, okay, if I multiply it, then the second matrix should be of size B comma whatever C. Then the output side will be A comma C. Okay, so this is the rule of matrix manipulation. When I'm performing matrix manipulation, the column of the first matrix should be the same as the row of the second, number of rows in the second matrix, and the output side will be this. Okay, so if I go back here in our question, so we have done already this. This was a 4x4 matrix. Then we are multiplying it with a 4x2 matrix. So originally we had 4,4. Okay, we are multiplying it with a 4x2 matrix. Okay, so our output was a 4x2, right? Okay, so if I look at it, this is a 4x2 matrix. Okay, now let's look at the second question. Create a random matrix of size 2,2 and multiply it with A. And can you guess what will happen? So can you guess what will happen? I believe you can actually understand. If I create a matrix like 2x2, let's do it first. So let's create it M2 is equal to ran of size 2x2. Okay, now if I try to multiply same A with M2, now it gives an error. Okay, you can actually go through the error to understand what it is actually saying. Error using this sign means the multiplication side, incorrect dimensions for matrix manipulation. Okay, because I am providing an incorrect dimension. Okay, I have to satisfy this law. This B has to be this B, otherwise it will provide me an array. So we cannot actually do this task. Okay, so let's look at the third question. Here we are asked to multiply the first row. This is the first row. Okay, first row with 2, 4, 6, 8. So let's copy it here. Copy. Okay, this is our M3. Okay, so this is our M3, and this is our original matrix. Now I only have to multiply the first row with M3. Okay, so if I try to take the first row, that is 1 comma all, first row all the columns is equals to A of first row all the columns multiple by M3. So multiple sign. Now if I do this, let's see what actually happens. I'm again getting an error. Why I'm getting an error? As you can see, the first row is a 1x4 matrix. I am multiplying it with a 1x4 matrix. But here that is something called that is called element wise multiplication. If you remember from your intermediate level, if you have something like this 2, 3, 4, okay, you want to multiply it with 4, 9, 6, something like this. If you remember the dot product, in the dot product we multiply 2 with 4, okay, multiply 3 with 9 and 4 with 5. This is what we call the element wise multiplication. Okay, So when I want to do something like this, that is called element wise multiplication, I use something different. I use this dot multiplication sign. Okay, it is also already given here. So if I use this dot multiplication sign, now I will see. So 16 is multiplied by 2, multiplied by 2, that is 32. 4 is multiplied by, sorry, 2 is multiplied by 4, that is 8. Then 6 is multiplied by 3, 18, and 13 is multiplied by 18, that is 104. All the other elements are remaining the same. So when you are actually trying to do this element wise multiplication, we'll use this sign, a dot multiply. Okay. Now another thing I would like to say, so say if I want to do something like this, multiply it, I want to multiply this one with 3, let's say 3, but now it is not showing any error, it is actually multiplying. The thing is that this is what is called broadcasting that I actually told you in the last lecture. When I'm multiplying by 3, it is already automatically creating a multiplication, okay, creating itself, generating itself, repeating itself, and then it is multiplying it with each of the element. So it is already automatically performing the element wise multiplication. But when you have an array like this and you want to multiply something like this way, element wise multiplication, you have to use this dot multiplication sign. Okay. Let's go to the next question. So divide a matrix A by 3. Okay, let's see what will happen. So I have this matrix, I want to divide it by 3. So this is the division sign, and I want to divide it by 3. Let's see what it happens. Okay, so this was 96, so 9 so it is divided by 5, it is divisible by 3. So this is actually divided, all the elements of this matrix actually divided by 3. Okay, so it is already performing this element wise division as long as this is a single number, integer number. If it is an array, then I have to use this dot division. Okay, let's write it here somewhere. So one is your multi and another one is your element wise multi. So for this one or this one, we will be using this sign. Okay, and when you are trying to do this element wise multiplication, okay, we'll be trying to use this dot multiplication. Okay, for division we'll be using dot division, something like this. Okay, I hope it is clear. Now let's go back. In the next question, add matching matrix of size 6 with A. Okay, let's see how it actually happens. So this is our magic matrix, this is our A matrix now. So one thing is that I didn't actually assign the value, I just divide the value, but it is not, if you look at it, the original matrix is remaining the same. When I'm dividing it, if I don't assign it, the original value will not change. Now the original value is changed, so I have to assign it first. It is unlike the C or Python. Okay, now let's do something that is called magic matrix, and name it M4. I have been asked to create a magic matrix of size 6. Okay, let's create a magic matrix of size 6. Okay, this is our magic matrix. Now we are asked to add this magic matrix of size 6 with A. If I try to add it, M4 plus A, can you guess what will happen? Again, error, because the matrix dimensions must agree. So if I want to add a 4 by 4 matrix with another matrix, that matrix has to be a 4 by 4 matrix, otherwise it will not work. So the matrix dimension has to be set. So if I write something like M4, instead of M4, if I write M5, that is equals to my magic 4, then if I want to perform this same task, M5 plus A, then it will actually happen. So matrix dimension has to be same, and this is actually just basic matrix. Okay, if you actually read the intermediate matrix chapter very nicely, this will be very simple to you. If not, I am just trying to go through the details as much as we can with our time constraint. Now the next question was subtract the identity matrix of size 4 with A. So identity matrix, if you remember the identity matrix from again from intermediate, it kind of looks like the first 1, then 0, then 0, then again 0, then again 1, then again 0, 0, 0, 1. This was like your identity matrix. Now to create some a matrix like this, there is a built-in function for that. As again, that is called, let's name it M6. That's equals to I. Okay, I of size 4. Okay, so this identity matrix is created, and we can just add it to our original matrix. So okay, we can just add it. So originally it was 32, now it actually become 33, and I think you can understand. So it was asked to subtract, sorry, we are asked to subtract the identity matrix from A. We have to do the subtraction, not the summation. So subtraction means A minus M6. So this is similar. For addition and subtraction, both are same. And extract the diagonal elements, the last portion, diagonal elements from A. Now how to extract the diagonal elements? Okay, the diagonal elements means, okay, these are the diagonal elements, right? So these three. If I want to extract, there is a built-in function for that is called diag. Okay, if I write this diag of A, it will actually give me the diagonal elements of A. So our A was something like this, both 32, then 3.66, then 2, then 0.33. So diag of A will take out the diagonal elements. Now if we actually try to look at this diag a little bit more, go here, let's type diag, and this is the first one I want to see. Okay, so you can see the diag same function can actually do two tasks. One is create a diagonal matrix or get a diagonal elements from the matrix. So this is what we actually did here. We get the diagonal matrix from a matrix, from a matrix, diagonal elements from a matrix. This is the task we done. We could also do something like this. So if you remember your diagonal matrix, let me show you. Let's say our x is 3, 5, 3, 5, 8, 1. Okay, comma 4. Okay. If I try to create a diag of x, okay, so this is the diagonal matrix. All the elements that I have created, put in the vector here, everything will be in the main row, in the main diagonal. All the other elements will become 0. This is what the diagonal matrix. So using the same function diag, we can create a diagonal matrix. We can also extract the diagonal elements from it. Okay. Now there is another interesting thing that I would like to say. You can try this one, diag v comma k will extract the kth element. So if I want to see something like this was our A, say I want to extract these elements, this not the main diagonal but the upper diagonal. So we can do something like diag of A comma 1. This is what it gives. It gives me 8, 3.3 and 4. This is the upper diagonal. If I write diag A comma 2, 3 comma 2, this is giving me 18 and 2.667. If I want below elements, below diagonal elements, I can do something like minus 2. Then it is giving me 3 and 4.67. So try to explore these things by yourself. Okay, I'm only showing you these things because you are in the beginner level. That's why I'm actually showing you all of those things. Try to learn this so that you can actually try to learn those things by yourself. Okay, so these are the this is exercise 7. So I have written the function names. Okay, you can actually try those things. I hope everything is clear so far.